and here's today's offering, which I've called efficiency of reactions. Now, in these calculations, there are two types. We're going to look at the idea of percentage yield and also the idea of atom economy. So I'm going to deal with percentage yield first of all. Now, in a percentage yield calculation, you're comparing how much is produced by how much it should be produced, which is called the theoretical yield. Now, that theoretical yield, as you know, you would calculate from a reactive mass calculations. Important things to know about percentage yield calculations. They will always be less than 100%. So if you've got more than 100%, you know you've made a mistake. And the reason this is because some of the product is lost in purification. So for example, if you're making a salt, some of it may be lost in filtering. Not all of the substance in the solution crystallizes. You may not have used enough of one reactant, or there could be anything else that can cause an experimental error. So let's go. So to calculate percentage yield, it's very simple. First of all, use a simple formula. Percentage yield equals the amount collected divided by the theoretical yield times 100%. So let's look at an example. So in the reaction here between magnesium oxide and sulfuric acid to form sulfuric magnesium sulfate and water, 5.6 grams of magnesium sulfate was collected, but the theoretical yield was 6.0%. What is the percentage yield? Now, as we can see from the formula here, the percentage yield equals the amount we collected divided by the theoretical amount. So in this case, percentage yield will equal the amount collected, which is 5.6 grams, divided by the amount we should have got, 6.0, and times that by 100. And when you work that out, that will come out as 93.3%. Now, as a percentage yield, that's pretty high. So you'd be very happy with that if you did that experiment. Now, just to show, you can also get this with gases as well. So in this reaction, we're reacting calcium carbonate with hydrochloric acid to form calcium chloride, carbon dioxide and water. 3.2 decimeter cube of CO2 was collected when the theoretical yield was 3.6 decimeter cube. What was the percentage yield? Now, if we go back to the equation at the start, percentage yield equals the amount collected, so that will be the volume of CO2 we're told, divided by how much should have been collected, and then times by 100 to bring it percentage. So the percentage yield, we collected 3.2 decimeter cube, but the theoretical yield was 3.6. So if we multiply that then by 100, and that will come out as 88.9%. Again, another really good yield. So really quite a straightforward calculation to do. Right, so moving on from that to atom economy. Now with atom economy, what this is looking to do is to find the most effective pathway for a reaction. So what we're looking to do to get the biggest yield and produce very little other product. This is important in industry because if you produce other products, that's a waste, and you've then got to purify your reactants, and you've also got to pay for removal of the waste. So really important, and they'll often choose, if there's 3 or 4 ways of making a product, they'll look at the one which has the highest atom economy. So the atom economy again is always less than 100% unless there is only one product. And if there's only one product, that atom economy has got to be 100%. So to calculate atom economy, we just use this very simple formula. It's the relative formula mass of the desired product divided by the total relative formula mass of all the reactants. So you work out the relative formula mass of all the reactants, add them together to give you that total, and then multiply by 100. Now, the example we've got here is what is the atom economy to produce hydrogen in this reaction. So, of the products, we've got 3H2. So that'll be 3 times the relative atomic mass of hydrogen, which is 1, and because it's H2, we've got 2 molecules, 2 atoms there, it'll come to 6. Now the reactants, we've got 2 reactants. We've got methane, which is carbon plus 4 hydrogens, which will come to 16. We've also got water, H2O. So we've got 2 hydrogens, atomic mass of 1, plus oxygen, which is 16, and that will come out as 18. So the total equals 16 plus 18 equals 34. Now then, to get the atom economy, so total RFM of the desired product is 6 divided by the total RFM of all the reactants, which is 34, times that by 100. So 600 divided by 34 equals 17.6%. Now, not the greatest of methods. The atom economy is pretty low, but this is in fact used because the raw materials which are using, methane and water, 1, they're relatively common and cheap to start with, and 2, they're easy to use. Right, I hope those 2 things about efficiency of reactions are straightforward and help you.